Yeah, so last talk of the day, last but not least. So I'm going to talk a little bit about BSD and Ansible. So by a show of hands, how many of you are using Ansible? Okay. Those who didn't raise their hands will after my talk. Okay, so I have a little bit of things that I want to talk about here. So first, I'm giving a short introduction, like the setting that I'm using Ansible in, and then some of the things that I found that are less optimal with shell script. I'm not bashing shell script. Well, bashing shell scripts. But I'm identifying some things that are less optimal in the modern way we are managing systems and deploying stuff on those machines. So that's what I'm going to talk in that section. And then I give a little bit of an introductory section about Ansible. I give a tutorial at EuroBSDCon in a couple of weeks. So that's a more elaborate thing and tells people what Ansible can do and what other cool stuff you can do with this. But this is more of like an overview talk, and in a little while I'm going to contrast the shell scripts against Ansible a little bit more. So my job, I always have to explain what I'm doing in the BSD world to other people, but in this crowd I have to do the reverse. I'm explaining what I do as a day job. Yes, I have a day job. I'm not 100% BSD involved, unfortunately. So I'm a laboratory engineer at my university, which is the University of Applied Sciences Darmstadt in Germany. And lab engineer is an interesting term, which is basically a sysadmin, except that I don't have a lab myself. I have a rack of machines that I manage. So we have a new study program that we're currently doing. In the last year, we started with that. It's called data science. Oh, it's a whole NoSQL and big data movement, and we want to get students ready for the workplace, working with these systems and these big data environments. So that's what I'm doing. I'm pretty much giving out systems or machines in this cluster. Well, it's actually not a cluster. It's just a rack of machines. I sometimes call it the Click Data Buster, just to mess with the name. So this is what it looks like, or at least a part of it. Yeah, there is some server prawn here. So what I basically do, I assign these machines to professors, students that are writing their thesis on, or combined projects with industry and the university. And it's basically setting all the machines up in a proper way so that the students don't have to worry about this, or that the professors can do their lab in a way that they are used to. And I also copy a lot of data back and forth to have them play with a little bit of data. So when I started with this a couple of years ago, I took over 28 Dell C6220 machines, and they were all set up by my former colleague, or a colleague that I'm sharing the office with, and he took another job, and I took over his job. And by the time I took it over, that this was a whole complete Ubuntu environment, I thought, maybe I can do something about this. And gradually, over time, I did. And so this thing has a central NFS file server that basically provides the home directories to the nodes in the rack, so that students can find the same files on all the other machines that they have access to. Currently, we also extending this cluster a little bit because, you know, if you have such a thing and students can play with this, the demand grows, of course, and now we have 40 nodes. They are now in a mixed FreeBSD Ubuntu environment because I'm gradually migrating to FreeBSD. And it's a process. I don't want to do it as a kind of a big bang thing. I want to have people get a little bit more experience with FreeBSD while having the option to switch back to Ubuntu if they have anything that they want to run on that. But slowly but steadily, people are using FreeBSD more and more, even if they don't know about it sometimes. So Beehive is a nice way of giving people their Unix environment that they want to have while still running on ZFS and on FreeBSD. So why would I talk about Ansible if I have such a nice environment? Well, so when I took over the cluster, we had an installation procedure that took 25 minutes. And for me, this was, well, this is a long time. I mean, these are machines that are normally relatively easy to install. And I was wondering why it took so long to install these. And that's how I got involved with the whole Ansible process. So if anyone of you is thinking that 25 minutes is way too long, then you're probably thinking the same thing as I do. So why is this happening? So I found out that the image that I was getting from our department's IT was the same image that they are using for the lab machine. So we have computer labs where students can do programming assignments and all that. But this image had basically everything that a server doesn't need. So graphics drivers, they had a full CUP stack, GUI tools were installed. They also had specially pre-installed NoSQL databases because why not? But on a server, I don't need GUI tools on a server. I don't need printer drivers on a server. And so I thought about doing my own thing. So that pretty much scratched my own itch to strip that full down. So now I have a way of doing a bare minimum installation of these nodes. I have a customized Ubuntu and FreeBSD ISO image that is only doing the very basic things. So it does the partitioning, or in ZFS case, it does the whole pool building and creates the data sets. You know how this works. And it installs the base operating system, setups the network, and then it reboots. It does nothing else. I want to get people to have as minimum as a downtime as possible to get them to multi-user mode again. And then I do basically the rest once the machine has been reinstalled. And the result of that is basically I managed to drop the install time by less than half of that time. So it takes like 12 minutes now, and I think it can even be less than that. And in FreeBSD, it's even less, so it's barely 3 minutes. I once measured that the boot time of these servers, detecting all the hardware that is connected to it and the peripherals, took longer than my shell install script. So that was a little proud moment for myself. And this is an ongoing process, of course. I'm trying to tweak here and there a couple of settings to make it a little bit faster. But I'm pretty proud of what I have currently. So, but once I'm back in multi-user mode, I have a need to install all the software for the professors and the students that are using these in the lab. So basically, this is involving configuration steps like setting up these 4 databases that you can see here. And of course, if we're doing Hadoopy things and we're always dealing with Java, so the first thing I always do is have a Java stack set up, and of course they always want to do the latest version, so I have to pull down the latest version as well. And there are dependencies, so Hadoop needs Java, and Pig is based on Hadoop, so if you install Pig, then it automatically pulls in Hadoop, and Hadoop detects that Java isn't installed yet, so it will pull down Java, and Couchbase and MongoDB are a similar setup. So this is something I can do in parallel then, because when I'm in single user mode in my ISO and I'm pulling down this ISO image, like in this 25-minute process before, this wouldn't be possible. But with Ansible, I can do this in parallel for I have 16 machines that I used for the labs that are coming up in the winter semester, starts in October. And I want to have this as a process that I can repeat anytime I want, and also that I have a defined way of installing this, so I'm not, oh, I forgot this one config file, or oh, I forgot this one setting to set. So I want to have this in a way that's working properly. And before I was using Ansible, I was using shell scripts for that. But I discovered some interesting scenarios that are less optimal. So what are the problems with shell scripts? Well, I have a prominent person who could tell you what's going to be the problem with that. It's, oops, I did it again. Because if you think about it, sometimes you are in the position where you are running your shell script accidentally twice or multiple times because you don't know, did I install that node already? I'm not sure. Well, okay, let's start it once more. What could possibly go wrong? Well, a lot of things actually, because then config files may have multiple lines in it and that shouldn't be there because they need to be unique the whole time. Or you set it to a different IP address, which confuses the configuration parser. Or you have some extra checks to prevent this in your shell scripts. But then it turns in, like your simple setup shell script quickly turns up into this whole, if this is already there, then skip this step and do the next. But this should be repeated first, and then remove the line, and then add it again. So this comes to a whole big mess of if this then that, take care of all eventualities. And undoing these steps is even worse. You're pretty much better off reinstalling the whole machine again just to be sure to have a pristine environment again. And that's less than ideal if you're doing this with a shell script. Don't get me wrong, I love shell script, and I'm teaching students how to write those with BinSH, of course, because that's the only interpreter you should use. And, but there's still a couple of things like repeating stuff all over again and applying the same shell script to your destination host that could turn into some of these problematic steps that I'm describing here. And sometimes you don't even know what kind of target machine you have. So you have installed a couple of machines a couple of weeks ago, and then you're like, was this a FreeBSD host? Was it an Ubuntu? I'm not sure. But I want to have one script that basically takes care of all this and doesn't need a lot of time to detect what is on the target machine installed. So Ansible is quite powerful in that regard because it has a way of detecting or not only detecting, but also works in an idempotent manner. Anyone knows what that is? Anyone? Okay. So I describe it a little bit. So every one of you pretty much did it when you came here to the conference because everyone walked up to the registration desk and picked up their badge and all the nice swag we got. But once you walked onto the registration desk a second time, you weren't given a second badge or a second swag. So that's what basically is in idempotency. So once an operation has been done, it isn't repeated again, and if it hasn't been done, it will be only executed once. And this is exactly what you want. If you're putting out configuration files or setting up a machine, you want to make sure that the configuration has been set once, but only once. And if you ran the script multiple times, the detection routines will discover that you already applied these settings and won't repeat them again. So Ansible does that, and this is a concept that other deployment or configuration management systems like the Puppets, the Chefs, and the salt stacks of these world are also based on. So Ansible is just another invocation, but it has also different properties that can be interesting for beginners in this area. So Ansible is pretty much a very lightweight way of starting with this, and it can run in ad hoc mode. So you can say, this 5 server group over here should just give me their current configuration file. Or they should just copy a file that I have locally and deploy them to a certain target directory. But once the scripts get more complex, if you have multiple steps, then you pretty much combine them into so-called playbooks. That's what they call them. And then you can have more elaborate scripts like download the web server, configure the web server, and then configure the database for it, and then set up your web stack on it. So that's all what Ansible can do in a playbook. And this is a typical scenario that we're now using on systems that we are deploying. So Ansible basically defines a control machine. This could be your laptop. It doesn't have to be a big server in your rack. It could pretty much any machine that you can run these commands on. And it basically retrieves these information and puts them out into all the machines, all the targets that you defined in a configuration file. I'm going to show this in a little while. And then they pretty much execute all their instructions on the target machines, and the channel between your control machine and the target machine is encrypted by SSH, and all the commands there are pretty much using SSH and to keep things secure and also in a well-defined manner. And the nice thing about Ansible is that you don't need a client running that executes and waits for instructions from the control machine. Ansible is pretty much just a Python environment, an SSH, and if you have that, then you can use Ansible right away, which makes it relatively easy to get started with. And Ansible also has a way of deploying stuff to itself. Like you can say the control machine should basically configure itself. So if you have a laptop and you have a new laptop and you always want to have your favorite configuration files in there, and you just run Ansible on itself. And that also is a nice way to manage your systems and making sure you, when you get a new laptop, have the same environment like the old one. And Ansible also, like the other configuration management systems, this is no different, it abstracts away the OS specifics. So you don't need to say anymore apt-get install or package install, or what's the other horrible thing called DNF, did not finish. So whatever package management this operating system uses that you're targeting, this is being abstracted away into like a package module. And these modules basically encapsulate all this functionality that you are trying to use. So copy basically copies files from your local to your target machine, fetch does the other way, and you can there are a lot of modules for very different purposes, like line and file. You can ensure that there's a certain line in a file at a specific position, and if it's already there in the idempotent manner, we'll prevent it from adding it again. So this is nice, and there are some specifics because Ansible was originally developed by Ansible Inc., and then Red Hat took it over. But Red Hat is actually quite open to other operating systems, surprisingly. And they have a specific section in their manual about setting up Ansible with BSD. And it's basically installing the Ansible port or the package on your control machine. Then you need to create an inventory file, which basically defines what kind of target hosts you have. And you need to provide a different interpreter line or the path to it, because the BSDs are clean and they use everything that's third party, and they place that under user local and not in etc or some other path that no one else finds again. In this case, I have just one host here, my BSD host 1, and you can already see that it's an ini file style configuration, and you can basically use these groups that you define. So if you have a group of web servers, you can also say, I have a couple of web servers, and then you can specifically target either the host names you defined or the specific groups to push out the configuration changes to all of these. And then there's a little chicken and egg problem, because you need to install Python on the target host, but if you set this host freshly up, how do you get Ansible to install the Python environment if you don't have access yet? So Ansible has a raw mode that basically uses very basic SSH commands to connect to the remote target and install or executes basic services. So that's why I'm not using the package module here, but the real package install command. But then the Python environment is installed, and after that you can use all the Ansible commands, like the ad hoc commands or the playbooks that you have written. So this is relatively simple, but you need to do this, otherwise Ansible won't run on your favorite BSD system. So here's the first example about what a playbook might look like. So this is a little stripped down version of a script that I'm using to allow students access to hosts that I have. So it basically defines a couple of sections. So this is in YAML, so everyone who loves using whitespace and tabs, this is your hell. And so basically we define a name. So the name is basically what the full playbook does, and it's kind of an informative string that is being output when you run this playbook. Gather facts deals with, which I'm going to explain in a while, getting information from the target machine, like OS information or network setup. So I don't need this in this case, so I can say gather facts false, so I don't need to collect the data from the target host. And then usually you have to provide what kind of targets this playbook should run on. But in this case, I'm using a variable. Yeah, this is a variable here to define this on the command line when I define or when I run the playbook. And then basically a playbook is basically a collection of tasks, and each task has a name. This is optional, but I encourage you to use that, because then you can find when something breaks, at which step this broke. And you can see in the first line, the first task is basically to edit sshd_config and add the allow users line, or use the already existing allowed users line to add another user ID to it at the end. There's a little regex problem here. Yes, if I'm using regex, I might have two problems. And then the rest is basically to restart the SSH service. You can also define that the SSH config file should be tested first before SSH is restarted. So in case you made an error in your little regex here, then you can be sure that the service won't be restarted unless the configuration file is parsed. So this is nice and not very problematic. If you get a little bit your head around into this, then you get started in writing these playbooks in no time. And this is how you execute this. So you pretty much started with Ansible-playbooks. The KB is because you need to make changes to the system itself, which requires root privileges. There are a couple of ways to get these privileges, either via sudo, which is the preferred method, or you provide a certain username that has only permissions to execute commands by Ansible. In this case, B is for getting the elevated privileges, like become a different user, and K is basically asking for interactive password entry. And then you define the name of the playbook. And here I define which host this playbook should run on and the user ID I want to add to my SSH config. And then the playbook will happily run, hopefully, and make the changes. And I don't have to worry about, did I edit the config file right? Yeah, I did, but I always forget to restart the SSH service. Yes, a couple of people smiling in the audience. They're doing the same thing. But with this, you pretty much, it's a fire and forget operation. Because once you've written this, then you pretty much just have to provide the host name and the user ID and don't have to worry about setting all these config files again. So here are a couple of more things that Ansible does for you. Basically, it takes away the tedious, repetitive tasks of doing all these configuration steps all again. So it takes a little bit of time to set these up. And once you get started, I could write yet another playbook to do one more task and one more web server to set up and one more automation here and there. You can also do repetitions, like in your shell scripts. You can have loops and iterations. You can also do like loops that are intersected with each other. And you basically list the items that are running over the loops, and then they are passed to the actual module, and they will execute all in parallel nicely and cleanly. It also abstracts, like I said, it abstracts the actual commands away, so you don't have to remember all these obscure options of your favorite archiving utility or what other deployment methods there are for, there are a couple of modules for deploying systems on like cloud providers, and they have some really crazy options sometimes, and this is basically just abstracted away in the module, and there's very good module documentation about these modules, what kind of options they take, and example scripts are also provided. And you can do multiple things at once in these setup steps. So you can say, create, copy a file, or fetch this file from a remote location, and while you're doing this, change the owner and the permissions. This is all in one logical step, and in shell scripts, this is there. I have a couple of slides there that have an example for this. And newer versions of Ansible, they're continuously developing this, and sometimes the pace is a little bit too fast for my taste, but as long as everything works that I'm using, I'm fine with it. So newer versions sometimes suggest that you should use a existing module that you never heard about before, and they will say, oh, look at this, there's a separate module for this, like use line and file module instead of running Z as a normal command. And if there's no module available, there's still a module available for running basic shell scripts or the command module for using pipes and all this. And of course, a setup step collects a lot of information for you that are normally not as available as you want to have it in a shell script environment. So you can use them as ready-to-use variables. So here I have a little bit more about these setup variables. So common problem when using shell script is you have to do a lot of magic or like grab set awk invocations to get like the IP address. So you have to do if config, pipe, grab something, get all these special characters out there. So there's no real way of storing certain information in Unix. We always resisted of having a registry that stored this information. So we have no way other than environment variables to get some kind of information from the operating system when doing shell script development. At least I haven't found it. And so Ansible basically does, when it starts in the playbook, does a fact gathering step. And this collects basically a lot of information about the operating system that it's targeting, like network information, subnets, IP addresses, DNS information, what kind of hardware it's running, what kind of disks are connected, date and time information, which might be important if you're doing work across time zones, what kind of partitions there are. This is more involved with Ubuntu because, well, why do you need partitions if you can run ZFS? OS distribution and kernel level. So if you want to do updates of your base operating system and want to detect which target machines already have a certain patch level, then you can do the setup step and only apply this to machines that have a certain older version. You can have complete access about environment variables, and you can get SSH host keys. So there's a lot of information in there that is gathered for you, and you can use it in your playbooks. So as I said, you can do multiple things in one command. So on the left side, I have Ansible. You can see from the length, it's a little bit more elaborate, but it's more compact together. The step that I'm doing is I create a user. I provide a name, a home directory, and a shell to use. And here I also say, generate me a little SSH key for it. Because when you create a user, that user probably wants to log into that machine. And I can also provide a key type for it. And in shell, I would have to use 2 steps. I would first have to use the user add command of pw, and then I would have to separately create the SSH key. I haven't found a way to do this in pw. But there are developers in the audience. They might be inclined to do this before breakfast. So there are other steps or module options for Ansible to do this. So you can also define like a comment in your SSH key or like the passphrase, because you always want to have passphrases in your SSH keys. So as I said, it's more combined together, the logical steps that are needed for creating a user account without having to run specific shell scripts or specific shell commands that are separate, because they're all separate invocation. In Ansible, it's one complete step, and then you can do the next step of doing something else with that user or using this user in other ways. But now some of the purists are saying, well, this is nice, but one does not simply replace binsh with Ansible. And that might be true. And again, I'm not against shell scripts in general, and I'm using them still. It's not a complete replacement that I'm doing. But there are things that Ansible can do better, in my opinion, and I'm trying to use both as much as possible. So if you want to make your playbooks work a little bit like shell scripts, then you can also do this, because pretty much a playbook is nothing else than a Python script, basically. And you can basically say in your header of your playbook, you can use this line here that says, well, execute it like /binsh, and you just use and provide a different interpreter, in this case, Ansible playbook. And then you make it executable, and then you can say /playbook name, and then provide local variables if you have some, and then you can use this in your rc.local scripts. When the machine starts, it will automatically execute this playbook, and you can work with it like it's a shell script. I found this out recently, and I pretty much rewrote all my shell scripts to have this line in the first line of the script, because it's so much more convenient than writing Ansible playbook, playbook name, and all these other options on the command line. This is much more shell-like. So what does FreeBSD need to work well with Ansible? Because it's not a first-class citizen. It's very close to what the Linuxes of this world are using, but there are some differences, of course. For example, if you compare the output from the setup results, or if you say, target machine, give me all the information that you can give me in Ansible, there are some differences in the output when you compare it with Linux and with the BSDs. So there could be a little bit more information about ZFS pools, partitions, well, not partitions, but data sets, and like a little bit more detailed network information here and there. They're quite good already, but it's still not on par with the Linuxes. And apparently, the Ansible folks, or the Red Hats that are now doing the development, are aware of BSD, and they're encouraging users to submit bug reports and fixes to be also a little bit better in the module area, because we currently have no modules for setting up jails. We have no modules for setting up beehives. We cannot create encrypted galley partitions. We cannot do anything with Guillaume, and it's not very good. If you're a BSD user, you kind of expect these things to be there because you want to use them. So we should keep up with vendors, and the Red Hat people should have a contact, or we should encourage the Red Hat people to take our patches, and we should have a way to communicate with them regularly to say, hey, this is a nice feature of BSD, and we want to have this automated on Ansible, and we should be able to collaborate in this regard better. Otherwise, the BSDs will be like pushed into the corner a little bit more, and it's all Linux at one point, which I won't like to have. But where FreeBSD scores in relation to Ansible and automation software, we have reliable network interface names. So I have installed a couple of machines with the newer Ubuntu versions, and each time they gave me a different network interface name. Craziness like this, like ENF0S0 or P1, and it's not ensured that next time you boot that this will be the same name because they dynamically generate those. And if you look online, they say, yeah, you can just disable this behavior with a little symlink, but this is out-of-the-box behavior and it shouldn't be the way it is. And the BSDs, or FreeBSD at least, is much better in this. They use specific driver manufacturer names and a number, because if you have multiple cards like this, then it gets enumerated. But it's very consistent, and there are no surprises there. In the Ubuntu world, or in the other, it's not just Ubuntu, they have all, a couple of distributions have took over this behavior. And if you're writing shell scripts or other scripts like Ansible, you first have to always do this detection step to just know what's the name of your interface device. Nah, not very good. So BSD is much better in this regard. We also have stable APIs and ABIs, so the users don't get these surprise effects of, oh, I'm switching to a newer version of the distribution and now everything is renamed and I'm not using the same APIs anymore, or they have different parameters. So this is the way that things should be, and the BSDs are better off having this stable API between major versions and not trying to switch around just for the sake of it. So there is an engineering effort in the BSDs that I think should be in other Linux distributions. And we also have a powerful and easy-to-use ports packages system. So when package-ng was developed for a long time, there was an Ansible module called package-ng, but now they have a module called package, which is even more general because it not only includes the BSD package system, but also the apps, the other systems of this world that other Linux distributions are using. So it's much more flexible. And you can always rely on the ports and packages system, which is a great effort by the ports people, and I think they don't get enough credit for that. But Ansible is no silver bullet, so there are some shortcomings you still have to do. And so for example, as you saw with the little comparison I had, it doesn't reduce the number of lines you have to write, so there's a lot of text that's been written, and if you're not a friend of YAML, then you pretty much start cursing the whole time because you did a little bit more taps here and there, or if you press return and your editor nicely indented your script line there, it will not run because if you use tabs in your YAML files, it will not parse correctly. YAML only uses like spacebar characters. Which will drive you to the brink of craziness, or you will suddenly look like me without much hair. But it's what they are using as a config file for their playbook syntax, and yeah, we have to live with that. Ansible by default also doesn't run as fast as it should, so by default it uses only like 5 forks, which means you can deploy to 5 machines in the default settings, and you have to tweak it a little bit if you have like 40 machines, or I know many of you will have much more machines than that. So there's a fork setting in Ansible config that you should increase to the number of machines that you have, because then you are sure that more parallel processes are deployed to these target machines. They also recently, or rather recently with I think version 2.0, they added strategies. So when your playbook runs, by default, each machine will wait to execute the next step until every other machine has acknowledged that this step ran, and you can see that it will be a long time before every machine, the more machines you have, the slowest machine will stop the whole other machines to execute their own strategies or their playbook steps. With strategy free, every host runs this on the same speed without waiting for the other machines to execute their steps in the playbook, and this is a much better way and faster way to distribute a lot of playbooks in a short amount of time. Ansible, there's also no way of converting your scripts or your shell script into Ansible syntax or into playbooks, so this is a manual step. So if you already have shell scripts, then you should probably put them in a little side window, and then start creating your playbook side by side, like step by step. And with that, you can also make sure that you can logically group commands together, like I showed you with creating the users and the SSH keys, which kind of gives you a way of rethinking why this shell script was supposed to be acting like it was. And maybe you're doing a little bit of tweaking here and there. There's also a problem with the whole architecture, because remember that our Ansible is always thinking about that you have a control machine and you basically push to a target machine out there. But if you have a thing like, I want to add automatically my generated public key to my authorized keys file, then it's problematic because you cannot copy a file locally from the target machine to the target machine itself, because it's always focused on copying from the local machine, your control machine, to the target host. There is a synchronized module that's acting similar to rsync. It's not completely the same, but you can say if you have 3 hosts, A, B, and C is your control machine, you can tell host A to copy files to host B. This is an option that you can do, but it's less than ideal if you're always thinking from the target machine or from the control machine that you have. So here's a couple of tips if you're starting the process of converting your shell scripts to Ansible. So as I said, you should go over it line by line and think about what does this line do and what's the appropriate module that you're using on the Ansible side. So there's a big list of modules for all kinds of actions you can do on a Unix machine. There's also Windows support, by the way. It's like now that they have basic support for a basic shell on Windows or a shell-like environment, they also have a couple of modules that run on that. Before that, they had specific modules written for Windows, and it had a different way of setting those up. But if you're ever in the process of manage Windows machines, then maybe you should think about a different career. No, that's fine. So you should also divide up your little shell script into logical parts, like creating users, installing a certain software, the configuration steps. All these should be separate parts in your Ansible module or in your Ansible script. And then you can make sure that you provide all the options that these modules are providing, because they're pretty powerful. They can do a lot of stuff. And I was always surprised that you can always set the permissions or the target group that it should have with just a simple few lines more in your shell script. You should always test your playbooks repeatedly, like you should normally do your shell script as well, because some modules act a little bit differently. So you think idempotency is strongly enforced, but sometimes it isn't. So I had instances where I still had multiple lines of the same config line that I added in a working shell script, or in a target directory. And it's something should be tested. So you don't just write the playbook and hope that it works. So testing is always a good thing to do. You should always make a habit of naming each step in your playbook, so then you can know when your playbook stops at some point and gives you an error that you know at which step this happened. You should also make use of loops and with items. So with items basically lists a couple of things that are passed to a module at the same time. And then you can basically make sure that you have, if you have repeated steps, then with a loop you can very much compress your little configuration file that you write. Or the current, like if you have to create 100 users, if you're doing this in a shell script, it's basically a for loop and a couple of invocations of that. And in Ansible, you can pretty much say, start at 1, end at 100, and that pretty much does the same in a relative compact written way in the playbook. There's also a template module. So templates are basically ways of providing your own configuration files, and when you deploy them to a target machine, the configuration files contain variables that are then filled out with the concrete values that you're having on the target machine. So this is a nice way of providing exactly the configuration files that you want to have, and not any other craft that's been added by other people. Also, return codes are provided as you are used to, and you should check those, because if one step doesn't finish properly or doesn't return success, and there's probably not a good way of continuing, because there might be some cases that are not in the right way that you should continue. So you should stop your playbook there, and if the return code is different than 0, then everything falls apart. It's the same with shell scripts. And again, as I showed you, you shouldn't gather facts if you don't need them, because it takes a little bit of time to collect these on a target machine, and a few seconds more or less can always make a difference. This is mostly important if you have a few short shell scripts, or playbooks in this case. If you have a lot of configuration steps, then it's more likely that you need to gather the facts, because you need like IP addresses and target directory names and all that. So in conclusion, I would encourage you to have a look at Ansible, because it's relatively easy to get started with. And the more tasks you repeatedly execute, you should get into the mindset of, why am I actually doing this 100 times per day? Or even twice per day is too much. You should write a little Ansible deployment script for that, and just fire and forget, and don't worry about it anymore, because then you can have all that in source control and make sure that you share it with colleagues maybe. There's also a lot of already written shell scripts on the web, on GitHub already, because people like to share these. And you can set up very complex web stacks and all kinds of crazy setups with Ansible scripts that someone else has written already. But it's no silver bullet, as I said. Writing these playbooks takes some time, but this time is actually well invested, because once you have written them, you just deploy them and use them many times, and it's a huge time saver, considering that you can execute them on multiple machines at the same time, and also get the benefits of having the idempotency of, if you ever be in a situation that you had to run this shell script again, or this playbook again, then you can make sure that some steps won't be running because they're already applied. And always keep in mind the clientless architecture, and that there is a central deployment machine where you're pushing these changes out into the target hosts. And that is basically the most, so I'm teaching a class of Unix for developers, and I have a small section about Ansible in there, and I started this last year, and I had students have a lab about write your little shell script to deploy some software into a jail, and then write the same script and deploy this via Ansible. And everyone was like, yeah, Ansible is nice, but why doesn't this script run? Well, you're using tabs. You're not using the proper YAML syntax. And they were more fighting with the YAML syntax than writing the actual script. So this is an interesting experience for me. Yeah, and with that, I want to say a few special thanks to VeriSign for organizing this whole conferences, especially Chris Gordon and Vincent Miller, and the whole organizing team, program committee, and a special shout out for Alan Jude for motivating me to submit this talk in the first place. And yeah, my university, of course, for letting me work with expensive hardware that they bought, and trusting me not to break things too much. And of course, you for listening. Thank you. Right on time. There's a first question.
I realize questions are the only thing standing between us and happy hour, so I'll try to keep this brief. You mentioned the importance of testing, and I was wondering what you've encountered as far as strategies for automated regression testing of Ansible scripts and playbooks.
Yeah, so currently I didn't do much regression testing, so I had already the shell script that had all the NoSQL databases that I had to install in it, and I basically tried each step and then deployed it on a target machine and compared what the output would look like in comparison to my shell script. I'm not aware that there's actually a regression testing framework for Ansible deployment or for configuration management utilities like this, but it would be good to have, definitely. Because you could write a playbook to verify that the deployment playbook worked correctly, that a certain file is in a certain directory, or that a certain service is now started, or other things. But there is I'm not aware of any such testing framework.
Thank you.
More work to do.
Yeah, I'm sort of wondering what your thoughts are on, if not Ansible itself, but something like it possibly ending up in base someday. It occurs to me that this is the one bit of functionality that Docker does that BSD hasn't been doing for 10 years. This ability to remote sort of create machines.
Yeah, putting stuff in the base system is always a discussion worth having. We try to keep the base system clean, and well, clean is an interesting word. We try to keep it small so that people that are using it on embedded devices or on servers that don't need much software have a very small environment. And I guess with package-ng, we'll get a lot more into that area. With Ansible, we should have a way to, because it just needs Python, it's relatively easy to install, but other configuration management software isn't that lightweight, and it needs a lot more configuration or even software to be pre-installed before you can do any kind of remote management. With all the other things that are now upcoming, like you also want to have a nice way of monitoring your machines as well. This might be a future talk that I'm giving. And it's difficult. It's a discussion we should have as an operating system developers group, because we're not just providing an operating system, we're providing a full set of utilities that should be easy for other people to use, and for like vendors or end users should have an easy time using this software without having too much of a setup step. Does that answer your question?
One more question.
Yeah, sure.
Is that something else? Thinking about taking something like Ansible and deploying it in a larger environment where you have multiple system administrators participating in the management, as well as other factors, it makes me uneasy to think that there's one central controller that can take over my entire infrastructure. Can you sort of point me in a direction for thinking about how to approach that problem and making it safer and less prone to catastrophic uses and misuses?
Yeah, this is pretty much the omnipotent root in a different form. If you have multiple people that are managing your infrastructure, then you should probably take a look at Ansible Tower, maybe. It's a commercial invocation of a management interface where you can say, these are the machines that this person can manage and only has access to deploy a certain set of scripts, or has permissions to run these 5 steps or these 5 scripts. But it's an organizational issue. I think you cannot completely solve this in software. You should have, so definitely you should have your configuration scripts in a version control system, because why not? And then you should provide only, because not every sysadmin is responsible for all machines. I don't think this is normal. You have database administrators, you have web server administrators, and only those people should run like the web server administration scripts or the database administration script. I mean, there's some overlap because there might be some integration there, but then you should do this in an organizational way and not try to do this in a software way. I mean, you can have permissions and all these things, but it's only a small thing you can do. And if people don't talk to each other within an organization and coordinate their efforts, then the best software can't protect you. And I guess, I know it's a very powerful tool. You run basically with the full permission set of root. And there are ways to strip this down a little bit with permission sets. I know, do you guys have anything that might contribute to this? You're using Ansible.
Yeah. So
There's the mic.
You brought up, some of the modules are.
Chris, go to the mic.
Yep.
Sorry. Some of the modules are lacking, or we may not have all the modules. It's actually really easy to write Ansible modules that do these things. They give you the boilerplate. It's Python, so caveat that if you like it or love it, you'll be writing in Python. Or in reality, you could write the modules in any language you want, as long as it pretty much returns some JSON in a certain format. So it's not hard to extend, either to do the OS functionality or to do some custom logic that you need in your automation. And then to the question about yeah, the fear of one person running a bad script across the entire environment. You can, again, there are multiple ways to skin the cat. Some of it's organizational, but you can break up your entire farm into multiple groups, multiple inventory files, and choose, okay, as draconian as you want to be to, these people only have logins and access to these certain hosts to keep that, or you only run, in one person, you could say, run on this group of hosts, and then run on this next group of hosts, very easily from the command line. So you can, you can control the dial on how painful you want to make, or how much risk you want.
Or how much trust you give to your...
Yeah, it's risk and
sysadmins.
trust. So if you have more questions, I can talk about it in more detail. Yeah, and any other questions? Anything else? All right, thank you, Benedict.
Thank you.
Thanks.